Hello friends, this is Gangadhar from the YouTube channel Maths Ganga, and in this video I am going to deal with the questions 14, 15, 16 from the RMO 2018. See, let us look at the question 14. See, the problem is of trigonometry from RMO 2018. The question consists of two expressions y and x. Y is the product of the cos terms where the angles 2, 6, 10 and 86. See, if you observe, the difference between the angles is 4 degrees. And coming to x is also a product of the cosine terms where the difference between the angles is 1 degree. And they ask us to calculate 2 by 7 times of the log y by x base 2. So initially you need to calculate y by x. For this type of problems, if you observe, here the difference between the angles is 4 and here the difference between the angles is 1 degree. So either we may raise the difference between the angles to 4 degrees of x, or we may reduce the difference between the angles for y to 1. So we can have two choices. So now I am going to raise the difference between the angles. Okay. So for that purpose I am going to use the two basic fundamental rules of the trigonometry. The first one is, if alpha plus beta is 90 degrees, then sin alpha is cos beta, whereas the other one is sin 2 theta is equals to 2 sin theta cos theta. See, so what is x? See, if you look here, the x is given like this, like cos 1, cos 2, cos 3, okay, like that. If you continue, in the middle you have that cos 44, cos 45 and then cos 46. And after that cos 46, if you continue, okay, you will end with cos 89. That means you will continue like cos 88 and then you can close it here with cos 89. Right? See, we have a logic here like that alpha plus beta is 90, then sin alpha is cos theta. So, since it is 89, so since it is 1, 89 plus 1 is 90. So you just write this cos 89 as sin 1. 88 plus 2 is 90. So write it as sin 2. Like that, if you continue from backwards, you can stop with cos 46. 46 plus 44 is 90. So you just rewrite that cos 46 as sin 44. Okay. And then cos 45 is the remains same. Now if you look, this is cos 1 and that is sin 1. This cos 1 and sin 1. So I mentioned the rule, sin 2 theta as 2 sin theta cos theta. So sin theta into cos theta is sin 2 theta by 2. So sin 1 cos 1. Cos 1 into sin 1 is nothing but, as by using the rule sin 2 theta by 2, that will be sin 2 degrees by 2. So sin 2 degrees by 2. In the same way, cos 2 and sin 2, that will be sin 4 degrees by 2. And in the same way, cos 3 and sin 3 will have, and that will be sin 6 degrees by 2. Like that, if you continue, cos 44 into sin 44 is nothing but sin 88 by 2 into cos 45. The degree value is 1 by root 2. Now if you observe, totally there are how many terms here? There are 44 terms with the difference of 2 degrees between the angles. See, basically the difference between the angles is 1 degree in the x. I reduced it to, I raised the difference between the angles as 2 degrees. Now again I use the same technique to raise the difference between the angles is 4 degrees. Okay, then I will stop. Now since the difference is 2 here, I go one more time with the same procedure. Now if you simplify it, there are 44 terms with 2 in the denominator, and if you collect the value, numerical value, which is 2 power 44 terms now, 44 into root 2. 2 power 44 into root 2, and then what we have here, sin 2 degrees and then sin 4 degrees. Okay, like that, if you continue, in the middle you have, since all these are even terms, sin 44 and then sin 46 and then you have at the end sin 88. To use the same logic, you just write this sin 88 as cos 2. Since 88 plus 2 is 90, sin 88 and cos 2 are same. Like that, the before term is cos 4 in the same manner, and the sin 46 is nothing but cos 44. So if you observe from left side onwards, sin 2, sin 4, sin 6 and sin 44, and from the right onwards cos 2, okay, and then cos 4, like that cos 44. So again if you combine, this is 1 by 2 power 44 into root 2, and here what we have, sin 2 into cos 2. Again use sin 2 theta formula. So sin theta into cos theta is sin 2 theta by 2. So sin 2 into cos 2 is nothing but sin 4 degrees by 2. Again sin 4 and then you have cos 4 there, that will be sin 8 degrees by 2. Like that if you continue, sin 44 into cos 44 is nothing but sin 88 by 2. Now if you observe the difference between the angles, this is 4 and this is 8, and next you will get it as 12. The difference between the angles is 4 degrees. How many terms will be there here? Up to 88. Since the difference is 4, 88 by 4 is 22. There are 22 terms with the denominator 2. So if you collect the numerical expression, 2 power 22. 2 power 22 and then 2 power 44 will give us what? 2 power 66. So, okay. So this is equals to 1 by 2 power 66 into root 2. And when coming with these expressions, just observe carefully. Here I have sin 88. So what is sin 88? Sin 88 is equals to cos 2. This sin 88 is equals with this cos 2. And before term is sin 84. Okay, since the difference between angles is 4 degrees now. Before this sin 88, I will have sin 84. This sin 84 and this cos 6 both are same. Like this, if you come, this sin 4 is equals to cos 86. This sin 8 is equals to the before term. Okay, since the sum of the angles 86 and 4 is 90, so sin 4 and cos 86 both are same. Like that, if you compare, the product of all these terms is equals to the product of all these terms. So I can write with, I can replace this product with y. So x on simplification I have that 1 by 2 power 66 root 2 into y. Okay, so what completely finally what I have a relation between x and y. So what I did here, if you observe, and I did here, I raised the difference between the angles to 4 degrees. Basically the difference between the angles in the given question is 1 degree. Once I applied this logic that sin alpha is cos of beta when alpha plus beta 90, and then I used the logic that sin 2 theta is 2 sin theta cos theta. From there I have the product of the sin terms with the difference as 2. Again I raised the difference to 4. Then this y and this sin product and cos product both are same. So replace with y. So I have that x is equals to 1 by 2 power 66 root 2. So what I am going to calculate? I need to calculate this 2 by 7 log y by x. But what I have here, this x is equals to 1 by 2 power 66 root 2. So send this x that side and the value that side. From that I have that y by x is equals to 2 power 66 root 2. 2 power 66 root 2 is nothing but root 2 is 2 power 1 by 2. And if you add the powers, you have that 2 power 133 by 2. Okay, fine. Y by x is 2 power 133 by 2. If you send this base to that side, you will get it as logarithm. Log y by x base 2 is equals to 133 by 2. But what we need to calculate? We need to calculate 2 by 7 into log y by x base 2. Okay, so 2 by 7 into log y by x base 2. Log y by x base 2 I have it as 133 by 2. So this is equals to 2 by 7 into 133 by 2. 2 and 2 will get cancelled. Okay, so 133 by 7. 133 by 7 is nothing but 19. Okay, 70 plus 63 is 133. So 133 by 7 is 19 and your answer is 19 for this problem. Okay, so what I did? Okay, initially I got a relation between x and y. I simplified x as 2 power 133 by 1 by 2 power 66 root 2y. So from there y by x is equals to 2 power 133 by 2. And on simplification we have log y by x and then 2 by 7 times of the log y by x base 2. And finally your answer is 19. Okay, so that ends the 14th problem of RMO 2018. And after that 14th one, we need to deal the 15th problem. The 15th problem is involved with the number 3, logical one. See, for the 15th problem, what they mentioned in the question. If you observe, they mentioned that a and b are the natural numbers. Such that, how the natural numbers are included here, such that 2a minus b, a minus 2b and a plus b are all distinct squares. Since they are all distinct squares, let them as x square and then y square and then z square. Now the question is, we need to calculate the smallest possible value of b. We need to concentrate on b. So they mentioned that a and b are the naturals. So automatically this x, y, z will be the integral values. Okay, since 2a minus b is x square, a minus 2b is y square, a plus b is z square, what I am going to do is to concentrate on b, just subtract y square from z square. That means a plus b minus of a minus 2b. From these two, if you subtract this a minus 2b from a plus b, you will get that 3b is equals to z square minus y square. And one more observation is, if you add these two, that is equals to the first one, 2a minus b is this one. So sum of these two is equals to x square. So what I have, x square is equals to z square plus y square. So x square is equals to z square plus y square, and from this we need to calculate the minimum possible value of b. So nothing but we need to calculate the minimum possible value of z square minus y square such that the difference is a multiple of 3, since 3b is mentioned. See, if you observe, x square is equals to z square plus y square, it looks like a Pythagorean triplet. Okay, the smallest Pythagorean triplet with the natural values is usually 3, 4, 5. So 5 square is equals to 4 square plus 3 square. See, we know that 3, 4, 5 is a Pythagorean triplet with the smallest natural values. Okay, and if 3, 4, 5 is a Pythagorean triplet, if you multiply this 3, 4, 5 with some other natural, it also gives us a Pythagorean triplet. Since we need to concentrate on the multiple of 3, so multiply these 3, 4, 5 with 3. So what we have? We have that 15 square is equals to 12 square plus 9 square. Okay, I multiplied 3, 4, 5 with 3. 5 3s, 4 3s and 3 3s. Now if you look, if you take this z square as 12 square and y square as 9 square, both are included with the 3, multiple of 3. So 3b will be the multiple of 3. So the possible value of 3b, and that too the minimum possible value of 3b is nothing but 12 square minus 9 square. So 12 square minus 9 square is nothing but 12 minus 9, 3 into 12 plus 9, 21. So by cancelling 3, you left with 21, and that 21 is the smallest possible value of p. Okay, so this problem is of usual logic and the number theory, and what we used here, we used the concept of Pythagorean triplet to solve this one. Okay, since 3, 4, 5 is a well-known Pythagorean triplet with natural numbers, from that we derived a Pythagorean triplet containing which are multiples of 3. So from there we answered that the smallest possible value of b as 21. Okay, there ends the 15th problem of pre-RMO 2018. And next we need to concentrate on which one? 16th problem. The 16th problem is somewhat a tricky problem, where it is mentioned that we need to calculate the summation of I plus j, where the values of I and j are running in between 1 and 10 such that I less than j, and then I plus j is equals to odd here. And we have another summation where we need to subtract the summation of I plus j. Here also the values of I and j are running in between 1 and 10 and I less than j such that I plus j is equals to even. We need to take the values of I and j from 1 to 10 such that I less than j, and if I plus j is odd, we need to add those sum values, summations, and if I plus j is even, add them and then subtract from this side. See, and whenever I plus j is odd, if both the number, if one number is odd and the other number is even, then only I plus j is odd. Whenever I plus j is even, if both I and j are even, or if both I and j are odd, then I plus j is even. See, since the values of I and j are in between 1 and 10, first 10 natural numbers, so better go with the normal counting procedure. So if I is equals to 1, what I am going to do is, if I is equals to 1, if I is equals to 1, then whenever I plus j will become odd. Since 1 is odd, we need to take even numbers. Since I is less than j, so we need to take even numbers which are greater than I and below 10, which are 2, 4, 6, 8, 10. So if I is 1, and if j is either 2 or 4 or 6 or 8 or 10, then I plus j is odd. That was my idea. And then if I is 1, whenever I plus j is even, since I is 1, we need to take the odd numbers greater than 1 and below 10. So 3, 5, 7, 9. So if I is 1 and j is either 3 or 5 or 7 or 9, then I plus j is even. So first of all, I list out all of those numbers and all. If I is equals to 2, then we need to concentrate on 3, 5, 7, 9. Since I is even, we need to write odd number for the place of j. Since I is 2, then j must be even, so we need to take 4, 6, 8, 10. And the same way, if I is 3, If I is 3, then 4, 6, 8, 10 are the values of j such that I plus j is odd. If I is 3, then what are the possible values of j? That must be odd. So greater than 3, 5, 7, 9. So if I is 4, here the values are 5, 7, 9. There the values are 6, 8, 10. And if I is 5, the values are, they must be even. So 6, 8, 10. And here the values of 5 are, they must be odd, 7, 9. If I is 6, since it is even, you need to write the odd. So 7, 9, greater than 6 and below 10. If I is 6, so there must be even values. So that will be 8, 10. And if I is 7, here the value will be 7 odd number. So we need to write even 8, 10. So if it is 7, I will write here 9 itself. If it is 8, it will be 9, and this is 10. And if it is 9, there it will have 10. No possibility here. I won't be 10. Since I is less than j, so clearly I value is largest possible value for I is 9 itself. No possibility for 10. Okay. Now, see, if you look, if the values of I are one, like this 1, 2, 3, 4, 5, 6, 7, 8, 9, then the possible values of j such that I plus j is odd. These are the possible values. To make I plus j is even, these are the possible values of j. Okay. So I listed everything. Now what I have to do? What I have to do? Okay. I have to do add all these values such that I plus j, and add all these values such that I plus j, and then subtract this summation from this summation. Okay. See, if you look what it means. 1 plus 2, 1 plus 4, 1 plus 6, 1 plus 8, 1 plus 10, 2 plus 3, 2 plus 5, 2 plus 7, 2 plus 9, and then 3 plus 4, 3 plus 6, 3 plus 8, 3 plus 10. Like that we need to add everything here. And the same with that, 1 plus 3, 1 plus 5, 1 plus 7, 1 plus 9, 2 plus 4, 2 plus 6, 2 plus 8, 2 plus 10. Like that we need to add everything here. So how we have to subtract? We have to subtract all these sums from this sum. Okay. See, once again look here. What I have? I have 2 plus 3, 2 plus 5, 2 plus 7, 2 plus 9 here. And I have 1 plus 3, 1 plus 5, 1 plus 7, 1 plus 9 here. So, these summations we have minus sign before that. So, finally what I have? This 1 plus 3 will become minus 1, minus 3, minus 1, minus 5, minus 1, minus 7, minus 1, minus 9. So, before these 4 I have minus sign. Before these 4 I have plus sign. So, these two will get cancelled. The same way, if you observe consequently, all these terms will get cancelled. Okay. See how we get cancelling. If you look, this will be like 6 plus 7, 6 plus 9. There I have that 5 plus 7, 5 plus 7, 9. Before that I have minus, plus 7, minus 7 get cancelled. Like that I cancelled everything. Okay. But there is no chance of cancelling these 5 terms. And one more task is, here what I have? 1 plus 2, 1 plus 4, 1 plus 6, 1 plus 8, 1 plus 10. I am adding, beside these 5 numbers, 1 also I am adding 5 times. Here I am adding 1 how many times? 4 times. So 5 times I added 1, 4 times I subtracted 1, still I left with 1. Here I added 2 4 times, I subtracted 2 4 times, so then no 2 is left there. Here I added 3 4 times and I subtracted 3 times, so I left with 1 more 3. Likewise, if you think, I left with 1, 3, 5, 7, 9. And if you add 10, 10 and 5, 25 is the sum value. Along with this, also we have these numbers. And if you add 6 plus 4 is 10, 8 plus 2 is 10 and 10, 30. So 30 plus 25, 55 is the sum. 55 is answer for the given problem. Okay, so this is the 16th problem of RMO 2018. What we did? We listed all the possibilities for I and j by fixing I such that I plus j or I plus j even. Then logically we calculated the summation. What is the logic behind that? For this sum we need to subtract that sum. With that logic we simplified and we left with the answer as 55. So this is the 16th problem of RMO 2018 and I will come back with some other questions. Thank you. Do subscribe for the channel.